everyone, the goal of this video is to learn how to solve rational equations, and you should also be able to identify some extraneous solutions in this context. So number one, your goal is to solve for x. If you look at the two sides of the equation, what you really have is a rational expression on the left and a different rational expression on the right. So what you're going to do is you're going to treat each side like you're simplifying a rational expression so you can get just one fraction on the left and just one fraction on the right. And this can be a lot easier to solve. So there's already just one fraction on the right, so we can ignore that for a second. And let's do some simplifying rational expression steps to make this one fraction. Okay, you're subtracting fractions, you have to have a common denominator. So what would the common denominator be here? This one's got an x plus 5, so this one needs an x plus 5. This one got an x minus 5, so this one needs an x minus 5. Okay, so what I'm going to do to create that common denominator, which is going to be x plus 5 and x minus 5, because that's what they have in common, is this one needs to be multiplied by x minus 5, and this one needs to be multiplied by x plus 5. Okay, and you're going to multiply the denominators as well, because really what you're doing is multiplying by 1, because like x plus 5 over x plus 5 is a fancy one. So the denominator is going to be my common denominator, and then I'm just going to kind of clean up the numerator here. So I have 1 times x minus 5 gives me x minus 5, and then I really have negative 2 times x plus 5, which is going to give me negative 2x and negative 10. Okay, and this is just the left side here, so cleaning that up, it looks like we have negative x minus 15 over my common denominator. And that equals our original equation had this x squared, 3 over x squared minus 25. Okay, so this is my new equation. It's a lot nicer to look at because I just have one fraction. So your goal is to use any of those simplifying rational expression steps so you get one fraction on either side. Now, how do we solve this? Well, if you notice, these denominators are actually the same thing written in different forms. So if I factor this, I have x minus 5, x plus 5. Okay, so I'm just even going to erase that and say that these have the same denominator. Now, let's pause for a second. Let me get this written down. And let's think about a simpler fraction for a second. If I said I have 2 over 3 equals x over 3, and I was solving for x, what would x have to be? Well, the only way these are equivalent is if the numerators are the same, because the denominators are already the same. So x would have to be 2. And you can look at rational expressions the same way. Their denominators are already equal, so once the denominators are exactly the same, all you have to do is set the numerators equal to solve. So I would set negative x minus 15 equal to 3. I'm not necessarily getting rid of the denominator, I'm just kind of ignoring it for a second because it's already equal, and all that needs to happen for the fractions to be equal is that the numerator is equal. So then I just solve this, add 15 to both sides, I get negative x equals 18, therefore x would equal negative 18, and you've solved for x. Okay, anytime you're solving a rational equation, you always want to check for extraneous solutions. The reason is because you're multiplying by this x minus 5, you're introducing a new x that wasn't originally there, so you could possibly create a solution that is false. Now, typically, the only thing that can happen that would make this false, maybe not the only thing, but the most common thing, is you can't divide by 0. So if I were to plug in this negative 18 and any of this would be 0, you can't divide by 0, and that would be extraneous. So you can go ahead and like plug this in and just make sure that it's okay. In this case, it will be, but double check if you don't believe me. So none of these denominators will be 0. I'm okay. Let's go on to the next one. I'm going to leave number 2 for you to try on your own because it's very similar. Now the next one is a little bit different. So we've got just a number here. So that's really like, if you want to make this fraction, 2 over 1. And if we want to add these things together, we're going to use our skills from rational expressions and simplifying them and add fractions. To add fractions, you need a common denominator. But first, we don't really know what factors this has. So what we always want to do first is make sure in its fully factored form. So the last one, what we were adding already was factored as much as possible. This one, it's not, so you're going to actually want to complete that step. So I'm going to set up my parentheses. What multiplies x squared is x and x. It's got to multiply to positive 10 and add to negative 7, so it's got to be minus 5 and minus 2. Now, this one has a denominator of x minus 5 and x minus 2. This one has a 1. So we don't need to add anything to this one. We just need to change this fraction so it has the common denominator. So I'm going to leave this as 3 over x minus 5 times x minus 2. Okay, now if I want this to have a common denominator, I'm going to have to multiply the denominator by x minus 5 times x minus 2. But whatever I do to the denominator, I'm also going to have to do the numerator. So x minus 5 times x minus 2 is going to be multiplied by that 2. I'm just going to rewrite that up here. Okay, so all of that, we have a common denominator, so we can add them. It still equals x minus 4 over x minus 5. And again, the point of creating this denominator is now you can say, what would I get when I add them together? So the denominator is going to stay the same, x minus 5, x minus 2. And I'm going to add the numerator. So it would be 3 plus this big mess of something that's going to need to be FOILed, right? Or double distributed. That was an x minus 4. So now you can go through the steps of kind of combining like terms, distributing that out, and getting something that's a little nicer to look at in the numerator here. So I'm going to pause the video and do that. And I want you to do that on your own just to practice some Algebra 1 skills. No cheating. Pause. Okay, check my work with yours. I went and FOILed this out, and I got x squared minus 7x plus 10, and then I multiplied by 2. But you might be noticing that, hey, I FOILed that out. That's where I came from right here. That was the original denominator. So couldn't I have just multiplied this 2 by this from the start? Yes, you could have. The reason I went and factored it is because sometimes in problems, you will have a factor here that's already in the denominator here, and you won't need to repeat that factor. It'll make your life easier. So you could have just multiplied the 2 by x squared minus 7x plus 10 on top and bottom, and it might have been a little bit simpler. I just did that for future reference. Anywho, if you've done correctly, you should get this here. I combined the 3 with the positive 20. That should have been 23 if I was doing this correctly. Okay, now I want to think about what I thought about up here and say, okay, if my denominators are the same, all my has to happen is that the numerators are the same. So this is an x minus 5. All it would need an x minus 2 to make these the same. So one option is you can multiply this by x minus 2 and this by x minus 2. Then it'll have a common denominator, which you can just set the numerators equal. Okay, or if we remember how to solve fractions from earlier, if I have like x over 5 equals 1 over 3, we can solve this by cross multiplying, which I could do here. But if you do that, the problem is you're going to have x times x in this row here. Or here you're going to have 2x squared times x, which is going to give you an x to the third. And if I have an x to the third, I don't know that I know how to solve that, which is why I am not going to do that here. So again, a lot of people say cross multiply. We just don't have the skills to do that at this point. I'm going to erase that for the sake of room. So I'm going to go with the method I used earlier, multiply the denominator and the numerator by x minus 2. So the left side will stay the same. 23 over x minus 5, x minus 2. Okay, now I have a common denominator, so x minus 2, x minus 5, but whatever I do the denominator, I have to do the numerator. And I'm just going to FOIL this out right here. So I have x times x gives me x squared, x times negative 4 gives me negative 4x, negative 2 times x gives me negative 2x, and negative 2 times negative 4 gives me positive 8. Negative 4x and negative 2x, you combine those like terms, you get negative 6x. And that's what you should have in the numerator. So now that the denominators are the same, again, all that has to happen is that the numerators are the same for these two fractions to be equal. So I can set 2x squared minus 14x plus 23 equals this. And then you got to figure out how do I solve this beast, which is why we spend a lot of times on quadratics. I guess that's not really why, but it's a benefit. Since this is a quadratic, you use what you know about quadratics. So when I'm solving a quadratic for x, I'm really solving for the x-intercepts. When we're looking at x-intercept, the y value is 0. So we need to get the equation set equal to 0. I'm going to move everything over to one side. So I'll do this. I'm just going to do it all in one step. Hope you don't mind. Cool. So all that will cancel. We'll have the equation set equal to 0, which is essentially saying your output is 0 because your y value of your x-intercept is 0, blah, blah, blah. Or you can think I need to use a zero product property. So we'll have x squared, and then negative 14x plus 6x will give me negative 8x. And I have 23 minus 8 will give me positive 15. And now this is a quadratic I can solve using the zero product property. So I will say what multiplies to be x squared is x and x. multiplies to be 15, but adds to -8 would have to be -5, -3. Okay, if you use a zero product property to solve, I know I'm going on the next page, but hopefully you have room, I would have x minus 5 equals 0, x minus 3 equals 0. So x is equal 5 and 3. I had to factor a whole bunch of times in this problem, at the beginning and the end. So factoring must be pretty important to solve a lot of math problems, huh? Anywho, I have my solutions, but you always want to make sure that they work. They're not extraneous. And let's say I plug in x equals 3. 3 minus 5 is okay. 3 squared minus 21 plus 10, that's okay. But what happens if I plug in x equals 5? So I'll have 5 minus 5 over here, which equals 0. Can I divide a number by 0? No, you can't. So therefore, our solution of x equals 5 is going to be extraneous. Therefore, it's a false solution. So I'm just going to say this is not a solution that works, and my only solution is x equals 3. So there's two reasons you want to check your answers when you're solving. One is to know whether you got the problem right or wrong. But in what you've learned in this chapter so far, you always want to check for extraneous solutions. So if you're doing a radical equation, if you're doing a rational equation like these, maybe even some absolute value in the future, always check. Moral of the story. Write that in big bold notes. Here's one more problem for you to try on your own, but otherwise, solving a rational equation involves a lot of the same things that simplifying a rational expression does. It's just when you get to the solving steps that you kind of have to think through what makes sense. You may have to solve some quadratics at the end, or if you're lucky, maybe it'll just be linear. And there's a lot of skills that go into this that we've been building up to. So put them all together, you get solving rational equations. If you have any questions, please make sure you ask them. Otherwise, do the on your own problem so you can self-assess. Have a great rest of your night.